fly by the comets, visit asteroids, visit the moon. There's a monolith, a very unusual structure on this. When people find out about that, they're going to say, who put that there? Who put that there?
The moon has been a subject of fascination and speculation for centuries, and with the advent of space exploration, numerous mysterious structures and conspiracy theories regarding NASA and the moon have emerged. The face on the moon, often attributed to a phenomenon called lunar pareidolia, is a fascinating example of how our brains are wired to recognize familiar patterns, like faces, in random visuals. Pareidolia, a type of apophenia, is essentially when we see meaningful connections in unrelated or random data. This specific lunar pareidolia first caught attention in 1976, when the Viking 1 orbiter captured images of the moon's surface. The most famous face appears in the Mare Imbrium, or the Sea of Showers, a large lunar plain. In these images, the interplay of shadows and hills strikingly resembles a human face with discernible eyes, a nose and a mouth.
It is the pattern of dark basalt rock that creates the face of the man in the moon, as we know it today.
However, scientific explanations have consistently debunked any notions of these formations being anything other than natural. The face-like appearance is purely a result of how light and shadow play across the moon's uneven surface at certain angles. This illusion fades under different lighting conditions. Later missions, particularly the Lunar Reconnaissance Orbiter, have provided high-resolution images clearly showing that these are just natural landforms like craters and valleys. This phenomenon has had a considerable impact on popular culture, sparking public imagination and featuring in various forms of media, often tied to themes of extraterrestrial life and ancient alien theories. NASA has played a significant role in demystifying this phenomenon, consistently explaining it as a natural feature and an optical illusion. They've used high-resolution images and scientific explanations to clarify the nature of these formations and taken this as an opportunity for educational outreach, teaching the public about lunar geology and the science of imaging and perception.
Between 1969 and 1972, 6 missions blasted off to the moon.
Wow, what a place! What a view, isn't it, John? It's absolutely unreal.
The theories about alien bases and UFO sightings on the moon, especially on its far side, have intrigued people for years. The far side's mystery, never visible from Earth due to tidal locking, makes it a hotbed for speculation. These ideas really took off during the space race and Cold War era, when space exploration was often mixed with elements of science fiction and UFO culture. Proponents of these theories often point to grainy images or videos, claiming they show structures or lights that hint at alien activity. Additionally, some base their beliefs on anecdotal reports from individuals who assert they have secret knowledge of space missions or extraterrestrial encounters. However, a closer look from a scientific viewpoint often reveals that these supposed sightings can be explained by more mundane causes. For instance, camera anomalies like lens flares or image processing artifacts can create misleading images. Also, natural geological formations, such as craters or lava tubes, might be mistaken for artificial structures. This is similar to how people see faces or other shapes in random patterns on the moon, a phenomenon known as pareidolia. Both NASA and the broader scientific community have consistently found no evidence of extraterrestrial life or man-made structures on the moon. Their stance is backed by extensive data from various lunar missions conducted by countries all over the world. This transparency challenges the idea of a cover-up and shows that the moon's geography is purely natural. Popular culture, particularly science fiction, has significantly shaped how people view the possibility of extraterrestrial life on the moon. This influence is amplified by the internet and social media, where unverified claims can quickly spread.
As the 45th anniversary of the Apollo 11 mission to the moon dawns, there are many mysteries about man's first lunar landing that remain unsolved. What did the astronauts actually encounter there? And what made NASA stop going back to the moon after Apollo 17?
You know, there's been a lot of talk about NASA cover-ups and classified information, especially theories that cropped up around the Apollo missions. This was a time when the Cold War cast a shadow of distrust and secrecy, and some people started believing that NASA had encountered signs of extraterrestrial life or ancient civilizations on the moon, but kept it all hush-hush. They point to things like altered photos, strange accounts from astronauts, and inconsistencies in mission transcripts. There's even a wild idea that ancient advanced civilizations left ruins or artifacts on the moon, and NASA's been sitting on this big secret. But when you look at it closely, these claims don't really hold up. NASA's always been pretty open with its scientific findings. They've shared a ton of data from lunar missions, and scientists all over the world, including those from countries not exactly friendly with the US, have had a chance to look it over. Plus, most of the so-called anomalies in photos can be explained by common issues like lens flares and shadows. And despite all the rumors, no astronaut from the Apollo missions has ever confirmed seeing anything out of this world up there. Then there's this spaceship moon theory. It's quite a story. The moon isn't a natural satellite, but an artificial one, like a giant spaceship or an observation station made by aliens. The theory points to the moon's size, orbit, and composition, saying it's all too perfect to be just a coincidence. They talk about the moon ringing like a bell when lunar modules landed, suggesting it might be hollow or metallic inside. But science has answers for these too. The moon's size and orbit line up with what we know about planetary formation.
These moon rocks are amazingly similar to Earth rocks, but they contain far less iron. This seemingly small difference offers a huge clue.
The lunar rocks we've studied are just like what we'd expect from a natural celestial body, and they share similarities with Earth's mantle. This supports the idea that the moon was formed from debris after a massive collision, which is the giant impact hypothesis. And that ringing, it's not because the moon is hollow. The moon just transmits seismic waves differently than Earth because of its dry, rigid surface. Now moving on, have you heard about the water ice they found on the moon? It's quite a fascinating story. Back in the 1990s, spacecraft observations hinted at hydrogen at the lunar poles, sparking theories about water ice in the moon's permanently shadowed craters. But it wasn't until missions like NASA's Lunar Reconnaissance Orbiter and India's Chandrayaan-1 came into the picture in the 21st century that we got solid proof. Chandrayaan-1's moon mineralogy mapper detected light reflections that were a dead giveaway for ice. Now this ice is tucked away in craters at the moon's poles, places where the sun just doesn't reach, allowing the ice to hang around. It's a mix of pure ice and some mixed with the lunar soil. This discovery is huge for lunar exploration. Imagine astronauts using this ice for drinking water, growing food, or even splitting it into hydrogen and oxygen for rocket fuel. It could open up a whole new world of deeper space missions. But of course, getting to this ice is no walk in the park. These regions are super cold, among the coldest in our solar system, so mining and processing this ice is a big challenge and a hot topic in space research. Switching gears, there's also this buzz about helium-3 on the moon. It's a rare isotope of helium here on Earth, but the moon has loads of it, all thanks to billions of years of solar wind bombarding its surface. What makes helium-3 super exciting is its potential for nuclear fusion reactors. It's a cleaner option that doesn't produce high-energy neutrons or much radioactive waste. People are already talking about how helium-3 could be the answer to our energy problems back on Earth. Its rarity and potential as an energy source make it quite valuable, economically speaking. But here's the catch. We're still figuring out how to mine and bring it back to Earth efficiently and how to use it in fusion reactors. Plus, there are concerns about the environmental and legal ramifications of moon mining. It's a complex issue, balancing the lure of a new energy resource with the responsibilities of space exploration and preservation. Did you know the history of lunar exploration is really fascinating? Way back in the 17th century, astronomers like Galileo were the first to peek at the moon's surface through telescopes. They noticed these craters and dark plains, which they called maria, Latin for seas. They initially thought these were actual bodies of water, but as we know now, those seas are anything but wet. They're actually vast, flat plains formed from ancient volcanic eruptions, less cratered than the highlands, suggesting a younger geological age.
You can look up from your own backyard and see impact craters on the lunar surface. There are over 300,000 craters, half a mile to over 500 miles in diameter on the lunar surface.
Talking about craters, they're these circular depressions caused by meteorite and asteroid impacts. They come in all sizes, some spanning hundreds of kilometers. Most of them were formed about 4 billion years ago during what's known as the Late Heavy Bombardment. Imagine the chaos back then, with the inner solar system getting pummeled by all these space rocks. These features, the craters and the maria, are super important for lunar studies. They tell us a lot about the moon's history and even the broader solar system's past. Scientists use them to date different parts of the lunar surface. But here's a twist. We used to think all major volcanic activity on the moon stopped about 3 billion years ago. However, recent data, including from NASA's Lunar Reconnaissance Orbiter, suggests there might have been volcanic activity as recent as less than 100 million years ago. They've even found evidence of small shield volcanoes. This throws a whole new light on the moon's geological activity, showing it's way more complex than we thought. This is crucial for future lunar exploration. It affects everything from where to land spacecraft to where we might find resources like water and minerals. But of course, this research isn't straightforward. We're talking about events that happened millions of years ago, and piecing this puzzle together requires a lot of data from remote sensing and analysis of lunar samples. It's a constantly evolving field, uncovering new secrets about our nearest celestial neighbor.
Saw this illumination that was moving with respect to the stars. We were smart enough to not say, Houston, there's a light out there that's following us. So technically, it becomes an unidentified flying object.
Have you ever looked up at the moon and wondered what lies on its unseen side? The moon's far side, often mistakenly called the dark side, despite receiving just as much sunlight as the side facing Earth, has been a subject of fascination and mystery for centuries. It wasn't until 1959 when the Soviet Luna 3 spacecraft sent back the first images of this hidden hemisphere that we got our first glimpse of what was there. This side of the moon is markedly different from the one we see. It's rugged, densely cratered, and lacks the large, dark basaltic plains, or maria that are so prominent on the near side. The moon's far side, largely hidden from the Earth, has been a fertile ground for conspiracy theories and wild speculations, largely because of its relative mystery and inaccessibility. One of the most persistent theories is that the far side of the moon harbors evidence of extraterrestrial life or even alien bases. This theory gained traction in part due to the lack of detailed imagery of this lunar region until the latter part of the 20th century, allowing imagination to fill in the gaps in knowledge. Some conspiracy theorists argue that structures visible in photographs from lunar missions are artificial, perhaps remnants of an ancient alien civilization. They often point to certain features that appear unnatural or too geometrically regular to be the result of natural processes. These claims, however, are typically based on misinterpretations of low-resolution images, where pareidolia, the human tendency to see recognizable shapes in random patterns, often comes into play. Another popular theory posits that the moon, particularly its far side, is a strategic observational post for extraterrestrial spacecraft monitoring Earth. Proponents of this theory often cite unexplained anomalies in radio communications experienced by Apollo astronauts when they orbited the moon's far side, suggesting these were attempts at alien contact or interference. However, experts explain that these anomalies were more likely due to technical issues with radio equipment or natural interference from the lunar environment. The idea of an alien base on the far side of the moon was further fueled by the mysterious termination of the Apollo program. Some theorists believe that astronauts encountered signs of alien life during their missions, leading to a hasty and secretive end to lunar exploration. They suggest that subsequent missions and satellite imagery of the moon have been doctored or withheld from the public to hide these facts. However, historical records and testimonies from those involved in the Apollo program paint a different picture, attributing the program's end to budgetary constraints and shifting governmental priorities. There are also claims that certain craters and other geological formations on the far side are perfectly shaped or positioned in ways that defy natural explanation, suggesting they are either alien-made or hold some form of hidden message or technology. These claims, however, lack substantial evidence and are generally dismissed by the scientific community. Despite these conspiracy theories, scientific missions and studies have consistently supported natural explanations for the features observed on the moon's far side. High-resolution images and data from various lunar missions, including recent ones like the Chinese Chang'e 4 mission, have provided detailed insights into the moon's geology, all pointing to natural formations and processes. The far side of the moon, often shrouded in mystery and intrigue, presents a landscape strikingly different from the familiar face that greets us each night. This hidden hemisphere of the moon, first revealed in detail by the Soviet Luna 3 spacecraft in 1959, is a tapestry of craters, mountains and highlands, a stark contrast to the Maria-dominated near side. One of the most striking features of the moon's far side is its rugged terrain. This side of the moon is heavily cratered and has fewer of the smooth, dark basaltic plains, or Maria, that are so prominent on the near side. The absence of extensive Maria on the far side has led scientists to surmise that the crust there is thicker, making it less susceptible to volcanic activity that formed the Maria. This difference in crustal thickness is thought to be a relic of the moon's formation and early history. When the moon was forming and still molten, heavier elements sank to its center, creating a denser mantle and crust on the side facing Earth. The most prominent feature on the far side of the moon is the South Pole Aitken Basin, one of the largest and oldest impact craters in the solar system. Measuring about 2,500 kilometers in diameter and about 13 kilometers deep, this colossal crater provides valuable insights into the moon's geological history. Studies of the basin have revealed unusual mineral compositions, suggesting that the impact might have been so powerful that it penetrated through the crust and into the mantle. This has significant implications, as it offers a rare opportunity to study the moon's interior composition. The lunar far side also hosts several other notable features, such as the Tsiolkovsky crater, named after the Russian space pioneer. This crater, with its complex structure and distinctive dark halo, is a subject of intense scientific interest. The halo is believed to be a result of volcanic activity, indicating that the far side of the moon was not always geologically inactive. Another intriguing aspect of the far side is the lunar highlands, an extensive area covered with peaks and valleys. The highlands are composed predominantly of anorthosite, a type of rock formed from magma. These rocks are lighter in color and older than the basaltic rocks that fill the Maria, providing a window into the moon's past. The highlands are pockmarked with craters, each telling a story of the moon's long history of cosmic bombardment. The far side of the moon also has fewer mascons, or mass concentrations, which are large areas of dense material sitting beneath the surface. Mascons are responsible for the gravitational anomalies that affect the orbits of spacecraft around the moon. Their scarcity on the far side further underscores the dichotomy between the two hemispheres of our lunar neighbor. The scientific exploration of the moon's far side, a region untouched by direct sunlight for centuries, has been a subject of immense interest and curiosity within the scientific community. This interest intensified following the historic moment in 1959, when the Soviet Luna 3 spacecraft first captured images of this mysterious lunar hemisphere. These images revealed a terrain vastly different from the familiar near side, with a lack of large Maria and an abundance of craters, igniting a desire to learn more about this uncharted territory. One of the most significant breakthroughs in the exploration of the moon's far side came with NASA's Lunar Reconnaissance Orbiter, LRO, launched in 2009. The LRO's mission, among other objectives, included mapping the moon's surface in unprecedented detail, providing scientists with critical data about its topography, temperature, and mineral composition. This data has been instrumental in enhancing our understanding of the moon's geological history and has helped identify potential landing sites for future missions. The Chinese Chang'e 4 mission, which landed on the moon's far side in January 2019, marked a new chapter in lunar exploration. This mission, which included the Yutu-2 rover, was the first to perform a soft landing on this part of the moon, achieving what had been a long-standing objective for space explorers. One of the key scientific goals of Chang'e 4 is to analyze the chemical composition of the lunar surface, particularly in the South Pole Aitken Basin, a vast impact crater that could offer clues about the moon's early history and its crust's composition. Chang'e 4 also carries instruments to conduct low-frequency radio astronomical observations. The far side of the moon is an ideal location for these observations due to its shielding from the Earth's electromagnetic noise. This makes it a perfect spot to study the space environment and solar bursts, and potentially to observe the early stages of the universe, free from the interference experienced on Earth. In addition to these missions, there are also proposals for building robotic and human bases on the far side of the Moon. These bases could serve as crucial steps in deep space exploration, including manned missions to Mars and beyond. The far side's unique geology offers opportunities for extensive scientific research, including the study of the Moon's tectonic activity and the testing of new space technologies in a challenging environment. Furthermore, the exploration of the Moon's far side could play a vital role in understanding the dynamics of Earth-Moon interactions. Studies of the Moon's crust and mantle on this side can provide insights into the thermal evolution of the Moon and its orbital dynamics, which in turn can shed light on Earth's geological history and the conditions that led to life on our planet. The far side of the Moon, often overlooked in favor of its more familiar counterpart, holds immense strategic significance for both scientific and exploratory missions in space. One of the key factors contributing to its importance is the unique radio silence it offers. Shielded from the Earth's electromagnetic interference, the Moon's far side presents an ideal location for deep space radio observatories. The absence of Earth-originated radio noise provides a pristine environment to study the universe in the radio spectrum, allowing astronomers to detect faint signals from the distant cosmos that would be lost in the cacophony of Earth's radio emissions. This radio silence opens up possibilities for studying phenomena such as the cosmic microwave background radiation and searching for signals from the early universe. It could also enhance the search for extraterrestrial intelligence by providing a clearer view of the cosmos, free from the clutter of human-made signals. Establishing radio observatories here could lead to groundbreaking discoveries in astrophysics, giving us insights into the formation of the first stars and galaxies, the nature of dark energy, and the evolution of the universe. Another aspect of the far side's strategic importance is its geology. The South Pole Aitken Basin, one of the largest known impact structures in the solar system, is located here. This basin is believed to have exposed the lunar mantle and could contain rocks with a different composition than those found on the near side. Exploring this basin could yield valuable information about the Moon's formation and its geological history, which in turn could shed light on Earth's early history and the conditions that led to life on our planet. Furthermore, the far side of the Moon is of interest for future manned lunar missions and potential permanent bases. The challenges posed by its rugged terrain and the lack of direct communication with Earth make it an ideal testbed for technologies that could be used for long-duration space missions, including those to Mars. The isolation provides an opportunity to develop and test life support systems, habitats, and other technologies in an environment that closely mimics deep space conditions. In addition, the Moon's far side holds potential for resource exploitation. The discovery of water ice in permanently shadowed craters, particularly near the lunar South Pole, is of great interest. Water is not only vital for supporting life, but can also be broken down into hydrogen and oxygen, providing fuel and breathable air for astronauts. The ability to utilize these resources on site could be crucial for the sustainability of long-term lunar bases and for future deep space exploration missions. The strategic importance of the Moon's far side extends to its potential as a stepping stone in human space exploration. Establishing a presence here could serve as a springboard for missions further into the solar system. The experience gained in operating in this remote and challenging environment would provide invaluable knowledge and skills for future exploration endeavors. And as always, I hope you enjoyed our video today. Thanks for watching.